Long before the age of instruments, they sailed to places most had never heard of through fog, over frozen seas, and beneath sunless skies. What guided them wasn't technology, it was something else entirely. Something far older, and nearly forgotten. In a world where direction came from the taste of seawater, the color of clouds, or the way a bird turned in flight, navigation was not measured, it was remembered. Let's follow their paths across wind, wave, and time, and uncover the silent knowledge that once ruled the sea. The Viking raid on Lindisfarne in 793 marked the beginning of what is now called the Viking Age, a period of Scandinavian expansion from the late 8th century to the mid-11th century. From the rocky coastlines of Norway, the forests of Sweden, and the low plains of Denmark, Norse seafarers began to travel not only for trade or exploration, but also for plunder, colonization, and influence. Within decades, their reach stretched from the Shetland and Orkney Islands to the rivers of Russia, and from the North Atlantic to the Mediterranean. This wide-ranging expansion required more than strength. It depended on the ability to navigate long distances across open water with accuracy. By 820, Norse ships were arriving regularly on the Irish coast. Settlements appeared in Dublin, Limerick, and Wexford. Raiding parties traveled inland via rivers and lakes, supported by vessels capable of navigating both shallow waters and the open sea. By the mid-9th century, Vikings were overwintering in England, building fortified camps called long forts. In 866, the Great Heathen Army captured York, renamed Jorvik, which became a key Norse urban center. These movements were not random. The precision required for repeated crossings, sustained raids, and long-term settlements indicated a reliable system of navigation and planning. In the east, Swedish Vikings known as Varangians explored river routes connecting the Baltic to the Black Sea. By 839, emissaries from the Rus, a group of Swedish origin, reached the court of Emperor Theophilos in Constantinople. Their journeys followed the Dnieper and Volga rivers, using portages to bypass rapids and areas of conflict. These voyages involved overland hauling of ships and the establishment of fortified waypoints. Their success was not based on maps or written directions, but on memory, observation, and cumulative experience passed orally through generations. Westward expansion was led largely by Norwegians. By 870, settlers were arriving in Iceland. Many voyages were guided by stories from earlier navigators. Nadod, one of the earliest explorers, was blown off course and landed on what he named Snowland. Garðr Svavarson later circumnavigated the island, confirming its geography. Ingolfur Arnarsson established the first permanent settlement in Reykjavik. Each journey contributed to a growing base of navigational knowledge built through repetition and observation. By the late 10th century, Norse settlers had reached Greenland. According to the saga of the Greenlanders, Eric the Red was exiled from Iceland and used that time to explore a landmass previously spotted by Gunnbjorn Ulfsson. Eric named it Greenland to make it appealing to future settlers. After returning to Iceland, he organized a migration fleet. In 985, around 25 ships departed. 14 arrived, a number that, despite losses, reflected effective long-distance seafaring over the 1,200-kilometer crossing. The Greenland colonies lasted for centuries, with the western settlement near present-day Nuuk and the eastern settlement near modern Qaqortoq. Around the year 1000, Leif Erikson, son of Eric the Red, sailed west from Greenland. He had heard of lands beyond the sea from Bjarni Herjolfsson, who had seen unknown coasts but did not land. Leif's expedition reportedly reached 3 places: Helluland, likely Baffin Island, Markland, probably Labrador, and Vinland, commonly linked with Newfoundland. At L'Anse aux Meadows, archaeological remains confirm a Norse presence, including turf buildings, ironworking, and artifacts consistent with known Viking practices. Reaching and returning from these locations demonstrated skill in reading wind patterns, coastal features, and ocean currents across the Labrador Sea and Davis Strait. Compared to many cultures of the time, Viking movements were remarkable in scale. Norse ships traveled through multiple ecological zones and latitudes without modern tools. There is no evidence that early Vikings used magnetic compasses or sea charts. Navigation depended on oral knowledge passed from master to apprentice. Sailors observed the sun's position, wave patterns, bird migrations, and cloud formations. Sagas describe lookouts climbing masts to spot whales or driftwood signs of land nearby. Norwegians expanded west to Iceland, Greenland, and Vinland. Danes moved west and south, raiding and settling along the British coast, Frankish Empire, and parts of Iberia. Swedes moved east by river into areas now part of Russia and Ukraine. Each direction required unique strategies. Viking navigation relied on environmental awareness and oral tradition. Place names like Helluland and Markland had both practical and cultural uses. Sites like Hedeby, Birka, Jorvik, and Lanso meadows reflect travel. Runestones referencing Miklagard and Vinland confirm this reach. The waters Vikings crossed during their expansion were neither uniform nor predictable. From the Kattegat between Denmark and Sweden to the Labrador Sea off North America, the North Atlantic was dynamic and often dangerous. Vikings navigated not only sheltered coastal inlets, but also volatile open seas where currents met, winds shifted abruptly, and dense fog could appear without warning. Understanding the geography, its patterns, hazards, and cues was essential for keeping course without the aid of charts or instruments. Early Viking movement began in the relatively enclosed Baltic Sea. This region, bordered by continental landmasses, offered safer conditions for initial coastal travel and trade. To enter the North Sea, navigators passed through the Danish Straits, especially the Øresund and the Great Belt. These narrow channels were influenced by tides and shifting sandbanks. Sailors had to adjust their course using local knowledge of submerged obstacles, channel depths, and seasonal wind patterns. Archaeological findings along the straits reveal long-term maritime use, with recurring signs of harbors and landing sites. Once into the North Sea, sailing conditions changed significantly. The shallow continental shelf extended far offshore, and the weather was unpredictable. Prevailing southwest winds dominated the region, while the North Atlantic drift, a branch of the Gulf Stream, carried warmer water northward along Europe's western coast. This meant voyages west to England or Ireland often required tacking against the wind, while return trips were more favorable. Knowledge of winds and ocean currents was passed orally, reinforced by seasonal experience rather than written documentation. Further west, beyond the British Isles, the Atlantic environment grew more complex. The Faroe Islands, about midway between Shetland and Iceland, likely served as stopovers. These islands were surrounded by fast-moving tidal currents and shifting weather. Fog banks were common, especially near cliffs. Currents between islands, known locally as raster, could reach several knots. Successful navigation through them depended on precise timing and an understanding of how tides interacted with landforms. Oral traditions in the Faroes preserved this seafaring knowledge long before writing became common. The stretch between the Faroes and Iceland spanned roughly 450 kilometers of open water, with few visible landmarks. Vikings called this kind of passage half-open sea. Here, the Irminger Current and the East Greenland Current played a major role. The Irminger, a branch of the North Atlantic Current, brought warmer waters northeast along southern Iceland's coast, helping maintain ice-free conditions during summer. This likely made the crossing to Iceland more manageable. In contrast, the East Greenland Current carried cold water and drifting ice southward, presenting hazards for those sailing toward Greenland or further west. Iceland and Greenland presented dramatic coastlines. Fjords carved deep into the terrain, and steep cliffs limited visibility but also served as reference points. Distinct peaks or ridges could be seen from afar and used as guides. Icelandic sagas mention specific landmarks used by returning ships. One example is Reynisfjall, near Vik on Iceland's southern coast, whose steep slope was both a navigational aid and a hazard due to nearby dangerous waters. Reaching Greenland involved an open-sea voyage of about 1,200 kilometers. The route passed through a zone where fog, ice, and changing waters converged. The East Greenland Current brought pack ice southward, often making landing impossible during certain periods. Sagas frequently reference drifting ice and the challenges it posed. Ships could be forced far off course or pushed southward. Greenland settlements eventually formed in more hospitable fjords on the southwest coast, near modern Qaqortoq and Nuuk, where conditions were milder and access less obstructed by ice. Beyond Greenland, the Labrador Sea introduced new difficulties. The waters were cold, visibility was often poor, and ice could linger into the warmer months. Despite this, Norse sailors reached North America, likely following the Labrador coastline before heading south. The sagas describe these regions as Helluland, Markland, and Vinland names, meaning land of flat stones, forests, and vines. These terms reflect practical observation and suggest that Viking navigators named new places based on recognizable features. Viking routes across the North Atlantic followed coastlines, currents, and seasonal patterns. They avoided straight paths, relying on environmental awareness. Experience showed which fjords were safe and when to avoid risky passages. Visual clues, watercolor, seabirds, driftwood signaled land. The saga of Eric the Red notes such signs in low visibility. Mental maps based on memory replaced written tools. Skills passed through tradition enabled consistent long-distance sea travel across medieval Europe. Viking navigation across thousands of kilometers of sea depended not only on environmental knowledge, but also on the vessel itself. The longship was a technological achievement, shaped by centuries of woodcraft and seafaring. Its structure allowed movement through both shallow rivers and deep ocean waters, giving Norse travelers the flexibility to raid, trade, migrate, and explore. Without this specific design, many Viking voyages would not have been feasible. The Gokstad ship, excavated in 1,880-inch Sandefjord, Norway, dates to around 890 CE, measuring 23.8 meters long. It had 16 oar pairs and a square sail. Constructed using the clinker method or lapstrake, its overlapping planks created a flexible, lightweight hull capable of enduring rough seas. The ship's shallow draft, about 1 meter, enabled passage through rivers, across sandbars, and landing directly on beaches. This made quick retreats and rapid shoreline movement possible. Its long, narrow hull offered speed and efficiency. Reconstructed longships have reached over 12 knots under sail and 5 to 6 knots using oars. Experiments with replicas confirm the vessel's performance. The Sea Stallion from Glendalough, based on the Skuldelev II ship found in Roskilde Fjord, Denmark, sailed from Roskilde to Dublin in 2007, covering over 1,000 nautical miles under controlled experimental archaeology. The voyage demonstrated that Viking ships were seaworthy in open ocean conditions and highly maneuverable in tight coastal areas. The square sail, typically made of wool and treated with animal fats or oils for water resistance, was central to longship navigation. Mounted on a single mast at the ship's center, it could be adjusted for changing wind conditions. Although square sails limited the ability to sail directly into the wind, experienced crews could tack at angles. Coordination between sail handling and oar rowing allowed ships to stay on course even in poor conditions. The steering system reflected Viking maritime priorities. Instead of a central rudder at the stern, Viking ships used a side rudder or steering oar mounted on the starboard side. This placement improved control near shorelines and during landings. The practice was widespread enough that the word starboard derives from the Old Norse term stýriborð, meaning steering side. While longships are often linked to raiding, their adaptability made them essential for trade and colonization. A cargo-carrying variant, the Nar, had a wider beam, deeper hull, and fewer oars. Designed for stability over speed, the Nar could carry up to 24 tons of goods, such as timber, livestock, wool, and grain. It was ideal for longer ocean crossings, including voyages to Greenland or Vinland. Unlike longships, Nars were built to withstand the heavy swells of the North Atlantic over extended periods. Construction details show practical considerations. Deck planks were often loose, allowing access to the bilge for bailing or for storing goods below deck. Some vessels had removable side planks to create rowing benches or expand cargo space as needed. Ropes were made from animal hair, tree bark, or seaweed, depending on what was locally available. Anchors, usually of stone or iron, were shaped to hold in rocky seabeds typical of northern waters. Crew coordination was essential for long-distance travel. Most longships needed 25 to 40 men, with roles divided among oarsmen, sail handlers, lookouts, and food preparers. Navigation was a shared task, requiring general awareness of wind, sea state, and ship behavior. The leadsugumadr, or lead navigator, directed the course, but responses to changing conditions had to be carried out smoothly by the entire crew. Entering unfamiliar fjords or sailing in fog demanded practiced coordination and quick adjustments. Resting during voyages was dictated by the ship's design. Crew members slept on deck under wool cloaks or makeshift coverings made from sailcloth. Exposure to wind and sea spray was constant, and warmth came from shared body heat. Fires were not allowed, so meals consisted of preserved foods such as dried fish, salted meat, hard bread, and fermented drinks. The ship's low profile reduced wind resistance and improved stability in crosswinds. Carvings on the prow and stern, often depicting dragons or animals, served symbolic or practical roles, possibly as protection, intimidation, or identity markers. The longship's design linked Scandinavia to distant regions, enabling travel through rivers, fjords, and open sea. From the Baltic to North America, these vessels made Viking expansion possible across unpredictable maritime environments. The Vikings traveled across wide stretches of ocean without using compasses, maps, or written navigation aids. From Norway to Ireland, Greenland, and Newfoundland, they relied on environmental observation. The sea, sky, and wind served as their guides. Orientation came not from instruments, but from experience, careful observation, and oral instruction passed across generations. This method, though unwritten, proved consistent across thousands of kilometers of open sea. The sun played a central role in direction finding. Without magnetic compasses, navigators relied on the sun's position. Westbound sailors kept the rising sun behind them and the setting sun ahead. Eastward return trips followed the reverse. On north-south routes, the sun's arc gave both direction and time. Shadows from the mast or rigging helped gauge progress relative to the sun's movement. Seasonal changes required adjustment. Northern summers brought long daylight hours, with the sun moving in a wide arc close to the horizon. Navigators used this steady motion for orientation. In winter, the sun remained low or disappeared entirely. Under those conditions, sailors relied more on routine, coastal features, and accumulated experience than celestial markers. Clouds offered indirect guidance. Certain formations, like lenticular clouds, indicated nearby land, especially when forming over distant islands or ridges. Low fog often hinted at ice or shoreline. In regions where fog formed consistently, sailors used it as a cue for land proximity before anything was visible. Birds gave further signals. Species like gulls and puffins rarely strayed far from land. When seen flying low in a consistent direction, they often indicated nesting areas ashore. The saga of Floki Vilgertherson describes one of the earliest recorded uses of birds in navigation. Floki released ravens at sea. The first two returned, but the third flew west and vanished. He followed its path and reached what became the northwestern coast of Iceland. Wind served both for propulsion and orientation. Square sails limited sailing angles, but crews learned regional wind behavior. In the North Sea during summer, prevailing southwesterlies pushed ships from Denmark or Norway toward the British Isles. The return trip required rowing or tacking against the wind. Seasonal wind shifts affected timing and safety. Fall winds were less predictable, sometimes offering faster passages, but with greater risk. Wave behavior was another source of information. In open water, long swells typically followed prevailing winds. Navigators read wave angles and compared them to the ship's heading. Shifts in wave direction could signal wind changes or current boundaries. Cross waves, two sets intersecting, sometimes marked convergence zones or nearby land. In fjords or enclosed areas, wave reflection off cliffs or constricted tidal flows created distinct patterns. Recognizing these helped sailors identify locations or hazards. Watercolor and texture also provided cues. Near shore, sediments, seaweed, or depth changes altered the appearance of the sea. Pale or greenish water often indicated sandbars or reefs. Floating kelp or debris suggested land was near. In colder regions, the presence of drift ice or slush hinted at glacial runoff or the edge of cold currents. In the saga of Eric the Red, driftwood was a sign that land was close when approaching Greenland. Temperature changes further reinforced observation. Sudden shifts in air or sea temperature marked transitions between currents. Near Iceland and Greenland, where warm and cold flows met, changes in air quality were noted by experienced crews. Moisture on sails or clothing could signal a shift in surrounding conditions, helping sailors recognize when they had entered a different water system. Though no maps were used, seasoned navigators Leithsugumen memorized routes through repetition and oral teaching. Instructions were often given in narrative form. After the sharp rock and before the long flat island, turn toward the setting Sunday. These cues combined visible features with timing to encode navigation into story-like guidance. Mountains or isolated rocks were identified by their appearance from the sea, not inland details. Navigation was learned through practice. Young crew members observed senior navigators, listening to verbal cues and watching decisions made throughout the day. Repetition built mental logs of cloud shifts, bird movements, and subtle wind changes. Modern experiments confirm these methods. Replicas like the Saga Sigler and Sea Stallion from Glendalough completed long voyages using only traditional cues. Without GPS or compasses, Vikings used sunlight, waves, and landmarks, turning environmental signs into a practical, experience-based system for reliable medieval sea travel. The Vikings crossed open seas without compasses, charts, or written instructions. From Norway to Ireland, Greenland, and Newfoundland, they relied entirely on environmental observation. Their guidance came from the sea, sky, and wind. Orientation was learned through direct experience and oral tradition, passed down across generations. Though never written down, this system reliably guided ships across long distances of open ocean. The sun was a primary directional tool. Without magnetic compasses, seafarers tracked the sun's position in the sky. When sailing west, the sun rose behind and set ahead. On eastward voyages, the reverse was true. Along north-south coastal routes, the sun's arc indicated both direction and time. Shadows cast by the mast or rigging helped track movement and estimate progress throughout the day. Seasonal changes affected how this was used. In northern summers, daylight stretched for long hours, with the sun following a low, broad arc. Navigators used this steady motion to maintain orientation. In winter, when the sun stayed low or disappeared, sailors relied on routine, local knowledge, and coastal landmarks, rather than celestial cues. Clouds offered further information. Some formations, such as lenticular clouds, indicated nearby land, especially when forming above unseen islands or mountains. Low fog often clung to water near coastlines or ice, signaling proximity to shore. In familiar regions, the appearance and movement of fog became a known part of the seascape, guiding ships before land was visible. Birds provided additional navigational help. Gulls, puffins, and other coastal birds rarely flew far from land. If observed flying low in one direction, they often indicated nesting sites. The saga of Floki Vilgerðarsson describes a navigator releasing ravens at sea. The first two returned. The third flew west and did not come back. Following that direction, Floki discovered Iceland's northwestern coast. Wind acted as both a force for movement and an environmental signal. Viking sails, square in shape, limited how far into the wind a ship could sail, but crews learned the seasonal wind patterns. In summer, the North Sea's southwesterly winds pushed ships toward the British Isles. Returning home often meant rowing or tacking against the wind. In autumn, winds were more variable, sometimes useful, sometimes hazardous. Waves provided direction when land was out of sight. In open waters, long swells often followed prevailing wind paths. Sailors read the angle of these swells and align them with their ship's heading. Shifts in wave direction could indicate a change in wind or current. In fjords and coastal areas, wave behavior changed significantly. Reflected waves or compressed tidal flows provided cues about narrow channels or approaching land. Water appearance gave further clues. Color and texture shifted near coasts due to runoff, kelp beds, or shallower depths. Pale green or yellowish water suggested sandbars or reefs. Floating seaweed or debris hinted at land nearby. In cold regions, slush or ice indicated glacial melt or the edge of the East Greenland current. The saga of Eric the Red mentions driftwood as a signal of landfall while nearing Greenland. Temperature changes in air and water also served as navigational signs. A sudden drop or rise could indicate crossing into a different current. Near Iceland and Greenland, where warm and cold currents met, condensation sometimes formed on sails or clothing. This shift, though subtle, was meaningful to trained observers. Though they used no maps, Vikings treated the sea as if it were one. Skilled navigators Leithsugumen memorized entire routes through oral tradition and practice. Instructions were shared in narrative form. After the steep rock and before the long island, turn toward the evening Sunday. These phrases encoded both time and direction, based on repeated observation. Landmarks were remembered for their appearance from the sea, not for inland features. Navigation was learned through experience. Younger crew members watched as elders interpreted clouds, wind, and waves. There were no written manuals. Lessons were reinforced by repetition. Environmental signs were committed to memory, not written down, but recalled in key moments. Modern experiments with replica ships like Saga Sigler and Sea Stallion from Glendalough demonstrated Viking navigation methods. Crews used no GPS or compasses, relying on sun, wind, waves, and animal behavior. This system of natural observation allowed them to cross vast, harsh maritime environments, just as Vikings did centuries earlier. Viking navigators depended heavily on the sun to maintain direction, but in the North Atlantic, cloud cover, fog, and haze often obscured the sky. Even under such conditions, Norse sailors managed to travel long distances. This raises a practical question. How did they navigate when the sun was hidden? One possible answer is the use of a sunstone. Although no sunstone has been definitively linked to Viking ship burials or confirmed in settlement contexts, several medieval texts and modern studies suggest the Vikings may have used a type of crystal to locate the sun's position when it wasn't directly visible. The mineral most often associated with this function is Iceland spar, a transparent form of calcite that displays double refraction. In 2011, researchers at Eötvös Loránd University in Hungary studied how Iceland spar might function as a navigational tool. The crystal splits light into two beams. By rotating the crystal and comparing the brightness of these two beams, a navigator could determine the direction of polarized light in the atmosphere. Because sunlight becomes partially polarized when it enters the Earth's atmosphere, especially around 90 degrees from its actual location, this method could reveal the sun's direction, even under full cloud cover. To use the stone, a sailor would hold it up to the sky and rotate it until both beams were equal in brightness. That orientation would correspond to the hidden sun's position. With training, this allowed for an estimate of direction when direct sunlight wasn't available. While it required skill, repeated use could make the technique practical for experienced seafarers. A 2007 study published in Proceedings of the Royal Society attested this concept. Using modern and reconstructed Iceland spar, researchers found that trained users could locate the sun within a few degrees of accuracy, even in heavily overcast skies. When combined with a shadow board, a wooden disc with a central stick used to observe shadow direction, this method offered further refinement. In the absence of visible shadows, the sunstone may have taken its place as a surrogate guide. Though not definitive proof, there is some textual support for the concept. The Ráðhulfs at an Icelandic tale dated to the 12th or 13th century describes King Olaf using a solar stone to find the sun behind clouds. The passage is brief and partly allegorical, but it introduces the idea of a physical object used to identify solar direction. Scholars have pointed to this as potential evidence for practical sunstone use during earlier centuries. Iceland spar deposits are found in Iceland and parts of Scandinavia, making the crystal geographically accessible to Norse communities. Its clarity and optical behavior would have made it suitable for this kind of application. Although the sagas do not describe its use in detail, the oral nature of Norse knowledge suggests that navigational tools could exist without being described in surviving texts. The sunstone's role would have been most useful during open sea crossings between places like Norway and Iceland or Iceland and Greenland. These journeys, often lasting days, passed through areas where fog and low cloud cover were common, especially in spring and early summer. A tool that could give even a rough sense of direction might help a crew stay on course before errors became too large to correct. Still, the sunstone likely served as a supplement, not a primary method. It would have worked alongside natural cues such as wave patterns, wind shifts, bird flight, and sea coloration. Even an approximate direction, when used with other observations, could be enough to maintain orientation between known waypoints. Reconstructed Viking ship voyages have tested this idea. In one experiment, navigators used Iceland spar in conjunction with traditional techniques during a crossing between Iceland and Greenland. Although cloud cover reduced visibility, the sunstone provided a close approximation of solar direction, helping the crew verify their heading. These results suggest that the method could be viable in practice. The absence of sunstones in archaeological finds may reflect their everyday use. Unlike weapons or jewelry, such tools might not have been buried or formally preserved. They were likely passed between crew members or replaced when damaged. Their absence in graves doesn't prove non-use. Whether all Viking crews carried sunstones or not, the concept aligns with their navigation style, focused on observation, adaptation, and practical tools useful in unpredictable weather conditions. No maps from the Viking Age survive to show how Norse navigators recorded their routes. There are no charts detailing the crossing from Norway to Iceland or the river paths of the Russes. Yet Viking sailors traveled those paths repeatedly and with precision. Their accuracy came not from written plans, but from memory. Navigation depended on mental maps built through direct experience, oral instruction, and repetition. In a non-literate seafaring culture, orientation relied on remembered sequences of landmarks, wind behavior, ocean patterns, and time intervals. Navigators known as leithsögumenn, route guides, memorized these environmental cues and passed them to younger crew members. Their knowledge was not symbolic. It was built from direct sensory contact with land and sea. A journey became a series of recognizable stages: a cliff that caught morning light, a change in wave pitch near a bend, or the duration until the sun reached a known height. Descriptions in sagas reflect this approach. Rather than naming distances or drawing coastlines, they recount sensory experience. In Erik's Saga Ratha, Bjarni Herjolfsson describes seeing flat stone land, then forested shores, and finally grassy hills. These became mental steps, visual markers to memorize and follow again. Future travelers used such accounts to structure their own mental maps, reinforcing them through personal observation. Place names reinforced memory. Norse toponyms often described geographic features. Helluland meant land of flat rocks. Markland referred to forest. These were not poetic names but functional labels. In Iceland, names like Reykjanes, Smoke Peninsula, Halfjörður, Whale Fjord, and Snæfellsnes, Snow Mountain Peninsula, described visible features. They allowed sailors to confirm their location through sight, matching landscape with spoken knowledge. Time was another element of orientation. Without mechanical clocks, Vikings measured progress using natural cues, sun height, number of meals, or known rowing durations. Travel was often defined by how many days it took under typical conditions. The Norway to Iceland crossing was generally estimated at 4 to 5 days with fair winds. Such time frames gave navigators a mental template to judge drift or delay. Repetition solidified memory. Major routes were traveled many times by different crews. Each trip added detail. A particular headland might be known for how it split the wind, or a bay for its unusual stillness. These features were shared orally. After the twin-peaked island, steer west to the hidden cove. Or, when the sea calms and turns green, the river mouth is near. Young sailors absorbed this information by sailing the route themselves, guided by those who knew it already. Mental maps also included known risks. Shoals, reefs, and poor anchorages were remembered through warnings. Some fjords were known for sudden gusts, others for tidal shallows. These hazards were shared in stories, keeping them in the memory of each new generation. The oral map wasn't fixed, it was revised over time as conditions or interpretations changed. Knowledge was often passed through rhythm or verse. While texts like Havamal weren't navigational manuals, they show a broader tradition of encoding practical information in memorable language. It is likely that route instructions, weather patterns, or even signs of landfall were conveyed using rhyme or repetition. In long voyages, these patterns made information easier to recall. The same principles applied to inland travel. Swedish Vikings trading along rivers like the Neva and Dnieper used mental maps to remember rapids, portages, and safe encampments. Some routes required carrying boats across land. Knowing when and where to stop or drag vessels was based on experience. In these cases, the map existed in the navigator's head. Sites such as Hedeby, Birka, and Dublin show repeated use, as do landing zones in Iceland and Greenland. Boat ramps, tent circles, and storage pits reflect habitual returns, guided by remembered geography. Modern studies confirm the effectiveness of such methods. Sailors trained in oral wayfinding, such as Polynesians or Arctic navigators, use similar mental models. They measure progress by feel, sight, and timing rather than instruments. Like the Vikings, they rely on learned experience, not written tools, to cross wide stretches of ocean. For Norse seafarers, the map was not drawn, it was memorized. Knowledge lived in shared stories, repeated practice, and careful observation. Navigation meant recognizing what had been seen before and passing it on to the next voyage. As Viking ships crossed long stretches of open sea, the natural world around them served as a guide. Among the most reliable navigational cues were living creatures. Birds, whales, and other sea animals helped Norse sailors recognize land, direction, and environmental change. These animals were not used systematically, but their behavior was closely observed, and their patterns became part of the oral knowledge shared among generations. Seabirds were especially important near coastlines. Species like gulls, puffins, guillemots, and fulmars had regular feeding and nesting habits. Most flew only a few kilometers from shore before returning to nesting cliffs, especially in the evening. When sailing near land, Vikings often saw these birds flying along steady routes, which could indicate the direction of the coastline, even when it wasn't visible through mist or cloud. The Landnamabok, the Book of Settlements, records an early use of birds for navigation. Floki Vilgertherson, an explorer in the 9th century, brought 3 ravens on his voyage from Norway. He released them one at a time. The first returned to the ship, the second circled and came back. The third flew west and did not return. Floki followed its path and reached Iceland. While partly legendary, the account reflects real practices, releasing birds to find land. Different birds serve different purposes. Species with fixed nesting habits were more reliable than migratory birds like Arctic terns, which could be misleading depending on the season. The sound of bird colonies, especially during breeding periods, often carried far across water. On calm days, these sounds could be heard well before cliffs or islands became visible. Whales and porpoises offered another source of information. These marine mammals traveled along known currents and feeding areas. In the North Atlantic, mink and pilot whales often surfaced near continental shelf edges where nutrients were abundant. Sailors learned to associate their presence with deeper waters or active fishing zones. If whales were moving in a consistent direction, it might reflect nearby current boundaries. Surfacing near shore suggested land was close. Whales also served as indirect warnings. Sudden changes in whale movement, erratic diving, or altered group behavior could suggest underwater obstacles or oncoming storms. On the Greenland coast, where rocks and drifting ice posed risks, these subtle animal cues helped inform navigational decisions. Though sagas rarely mention whales as guides, their regular appearance in voyage accounts suggests they were part of sailors' broader environmental awareness. Schools of fish, especially herring and mackerel, were another indicator. These fish moved in predictable seasonal patterns, influenced by temperature and plankton levels. For Vikings, the arrival of specific species marked changes in the season. Observing their presence helped time longer voyages. In shallow coastal waters, large fish schools could darken the sea surface, making it easier to identify bays or estuaries. Seals offered clues in nearshore waters. Found on rocky coasts and offshore islets, they tended to return to consistent haul-out sites. Their calls or splashing could be heard even in poor visibility. At night or in fog, these sounds helped crews confirm proximity to land. While seals were hunted for meat and hides, they were also part of the coast's natural signature, aiding in approach and landing. Even animals aboard ship were observed. Dogs, sheep, or birds, brought for food, sometimes reacted to subtle environmental changes. Shifts in scent, wind, or air pressure might cause restlessness, which sailors sometimes noted as possible signs of nearing land. These responses were not precise, but when combined with other observations, they added another layer of awareness. This form of navigation was not based on any single animal or behavior. It was cumulative. A lone bird meant little, but a steady flight line paired with a shift in wave direction or a faint bird colony call could build confidence in a course. Vikings interpreted these signs not in isolation but as part of a larger environmental picture. Animal behavior played a vital role in Norse navigation, especially when landmarks were absent. No instruments were needed, just observation and memory. Birds returning to cliffs, whales in deep channels, or seals at dusk became cues shared through oral tradition. Animals weren't trained, they were watched. Their behavior, like wind, sun, and waves, formed a natural system. For Viking crews, reading these signs was key to surviving an unpredictable maritime world. In the vast and often featureless seascapes the Vikings sailed, not all guidance came from what they could see. When fog, darkness, or overcast skies obscured visual cues, sound and smell offered vital information. Especially near coasts and settlements, these sensory signals added depth to a navigator's perception. The sea did not fall silent when unseen. It revealed itself through echoes, scents, and the movement of air. Many Norse settlements were built near fjords, islands, or rocky shores, where acoustics changed noticeably. Experienced sailors began to associate specific sounds with particular places. The crash of waves against a certain cliff, or the echo produced in a narrow inlet, became recognizable signatures. A hollow return might signal the mouth of a fjord, while a more scattered sound could mark an open bay. These patterns, while not measured, were learned through repetition. In fog or low visibility, sound became a primary reference. Quick, sharp echoes warned of nearby cliffs. The noise of waves breaking suddenly in an otherwise calm sea suggested hidden rocks. Crews learned to listen carefully as they approached land, interpreting subtle shifts in volume and delay. Younger sailors absorbed this by traveling repeatedly with more experienced crews, who pointed out what to notice and how to interpret it. Seabirds added another layer to the auditory environment. Cliffs that hosted nesting colonies were rarely quiet. The calls of gulls, puffins, or fulmars echoed across the water, especially during breeding season. These sounds traveled far on still air, offering an early indication of land. Because colonies returned to the same nesting sites year after year, their location became dependable markers. Settlements also contributed to the soundscape. Though not intended for navigation, everyday noises like barking dogs, voices, or the clang of metalwork could drift out to sea. Bells or horns used during festivals or religious observances occasionally reached passing ships. These incidental sounds were not relied upon, but could confirm what the crew already suspected, that a known port or village was nearby. Smell played a subtler but important role. The human sense of smell can detect faint organic traces carried by wind. As ships neared land, especially in inhabited or vegetated regions, sailors could pick up on scents not found at sea. The smell of peat smoke from turf fires, wet soil, pine forests, or rotting seaweed often signaled that land was close. In places like Iceland or the Hebrides, peat fires were common, and their distinct scent became a recognizable indicator of habitation. In forested areas of Scandinavia, the aroma of pine resin or leaf litter sometimes reached ships before land came into view. In coastal regions, tidal flats or drying seaweed added sulfuric or earthy smells. These changes, though often faint, could be noticed by crews attuned to their surroundings. Combined with wind direction and other cues, scent became another part of the mental map. At night, or during early morning sailings, when sight was limited, these non-visual signals became even more important. The echo of water against a known rock, the smell of coastal vegetation, or the muffled calls of seals could help a crew confirm position. In the long twilight of northern summers or the darkness of overcast winter days, the senses worked together to keep the vessel on course. These methods were never used in isolation. They were part of a larger navigational system based on observation, memory, and collective knowledge. No single sound or smell determined course, but together they offered a fuller picture. When the stars were hidden and the coastline invisible, the smell of earth or the cry of a nesting bird might be enough to suggest that a familiar inlet was near. Though such techniques leave no archaeological trace, they are consistent with oral traditions found in other seafaring cultures. Like Pacific Island navigators and Arctic hunters, Norse sailors used the full range of human perception to interpret their environment. Their world was not navigated with tools, but through sensory immersion. They knew the sea not as a blank expanse, but as a place layered with meaning, sound, scent, and remembered experience. Viking crews navigated with more than sun and wave. They listened for cliffs, smelled distant fires, and remembered how sound moved through rocks. Even in fog, they found their way using wind, water, echoes, and the sensory knowledge passed through experience. In the Viking Age, weather was more than background. It shaped when voyages began, how they were conducted, and whether they ended safely. With no meteorological instruments, Viking sailors relied on close observation of sky, wind, and sea behavior. This knowledge was not theoretical, it was practical, passed through lived experience, and essential to survival on open water. The North Atlantic's conditions changed rapidly. A calm morning could become a stormy afternoon. Fog arrived without warning. Viking ships, though designed for speed and agility, remained exposed to weather. Square sails and open decks made them vulnerable to strong winds, especially if taken by surprise. Recognizing early signs of change was critical. Clouds were among the most trusted weather indicators. High, thin cirrus clouds suggested fair conditions. Low, dark cumulonimbus clouds often signaled storms. Sailors studied cloud movement and formation. Rapid motion from the west frequently meant incoming rain. Sky color offered cues, as well yellowish tones at sunrise hinted at poor weather, while red skies at night were viewed favorably. These patterns, passed down through sayings and habits, influenced decisions on when to sail or seek shelter. Wind behavior was closely monitored. It powered the ship and warned of coming shifts. Sudden gusts from new directions, or a drop in wind speed, raised concern. A warm wind from the south usually meant stable weather. A cold gust from the north might suggest ice or storms, especially in spring and autumn. Sailors tested wind with their hands and faces, observed its effect on sails, and judged its pressure by feel. Over time, these tactile signs became a reliable vocabulary. The sea's surface added further information. Long, steady swells suggested consistent weather. Short, erratic waves hinted at change. In fjords or coastal areas, tide shifts and altered current speeds warned of coming storms. A dead calm, where the sea became unnaturally still, sometimes indicated pressure drops and approaching instability. These surface patterns, once recognized, helped sailors anticipate what was not yet visible in the sky. Animal behavior added clues. Seabirds flying inland or falling silent often preceded storms. Whales or dolphins surfacing more often or disappearing could also suggest weather change. While not scientifically explained at the time, these repeated observations became reliable cues. If bird colonies quieted and the wind shifted, the wise choice was to find shelter or delay sailing. Ice posed another hazard. Near Greenland or in colder seasons, temperature changes were noted by the feel of the ship itself. Cold currents made the hull heavier. Mist hugging the water surface hinted at nearby ice. Crews watched for slush or small floating pieces, often the first warnings of larger ice ahead. Sound also helped. Ice cracking or echoing across the sea could alert a watchful crew before visual contact. Seasonal timing influenced decisions as well. Voyages from Norway to Iceland or Iceland to Greenland were usually planned between May and August. Calm conditions were more likely, Even then, crews waited for the right signs before departure. A clear morning sky and steady breeze encouraged launch. Shifting wind, falling air pressure, or strange clouds led to delay. In the saga of the Greenlanders, storms are described in vivid detail, showing the dangers faced when such signs were missed. Surviving them was not only about strength, it marked skill and deep familiarity with nature. Weather reading was a shared responsibility. While the navigator led, all crew members contributed. One might note a shift in wave pattern. Another might observe a new cloud form. These inputs formed a collective awareness, refined over time. Lessons from past storms became part of the crew's memory. A gust ignored once would not be ignored again. Modern reenactments confirm these methods. Crews on reconstructed ships like the Sea Stallion from Glendalough reported relying on sky color, cloud density, and the feel of wind, just as Viking sailors had. Even with modern support tools, they found traditional observations still relevant. These experiments support what Viking crews knew. The sea and sky constantly offer information. The challenge is recognizing what they say. For the Vikings, watching the weather was an active discipline. Every cloud, breeze, and ripple on the sea told part of a story. Reading it correctly meant safety. Misreading it meant risk. No compasses or forecasts were available, just the sky above, the sea below, and the knowledge carried by those who had sailed before. For Viking sailors, one of the most dependable navigational methods came not from tools or the stars, but from the land itself. When visibility allowed, they used coastal piloting, navigating by observing and remembering features along the shore. Every headland, fjord, island, or rock formation served as a reference point. These cues were not recorded on paper, but passed through memory and oral instruction, forming a shared mental map shaped by repetition. Coastal piloting involved moving from one known landmark to another, adjusting course as the landscape unfolded. Distance was not measured in fixed units, but in travel time. Sailors would say, 3 watches from the river mouth to the red cliff, or half a day to the island shaped like a shield. Along the fjord-rich coasts of Scandinavia, distinct features, such as stained cliffs or double peaks, made such markers easy to remember. They were reinforced through stories, instructions, and frequent use. Sagas offer scattered references to this form of sailing. Voyages often began with statements like, "They set out northward along the coast," followed by mentions of specific harbors or promontories. In Heimskringla, ships are described as sailing under the land, implying close travel along shorelines using visual reference points rather than open sea estimates. The importance lay not in the distance between places, but in knowing the sequence of visible features. A clear example appears in the Othere Report, a 9th century account presented at King Alfred's court in England. Othere, a Norwegian seafarer, described sailing around the North Cape and into the White Sea. His report didn't list distances by measurement, but described landmarks in sequence. This method, naming headlands and bays as they appeared, reflected practical seafaring, focused on what could be seen, not abstract coordinates. As ships approached land, the shape and angle of coastal features revealed orientation. From the sea, cliffs, mountains, or slopes had distinct silhouettes, helping crews identify locations. Some places were named for how they looked from offshore. Hvitserkur, a pale sea stack in Iceland, means white shirt, a reference to its appearance against dark cliffs when viewed from the water. Islands and skerries served as stepping stones, especially along the coasts of Denmark, Sweden, and in the Baltic. In these areas, small islands formed a chain, allowing navigators to sail without needing to see the mainland. Moving from one islet to the next offered a safer alternative to open sea travel and provided shelter during bad weather. Successful coastal piloting also required knowing which features could mislead. Some bays were too shallow to enter safely. Others looked identical from a distance, but led to different outcomes depending on tide or wind. In unfamiliar waters, crews relied on a leithsugumathur, a guide who had traveled the route before. These individuals earned trust through experience. They remembered which river mouths were passable, which rocks to avoid at low tide, and which headlands marked turning points. Conditions changed with seasons. A river might swell with meltwater in spring, altering its appearance. Fog lingered longer in valleys during autumn. Wind direction could shift how cliffs looked from afar. A landmark reached quickly with a tailwind might take much longer to reach under adverse conditions. Navigators adjusted for these differences, integrating them into their mental framework. Some settlements made themselves more visible to sailors. Fires were sometimes lit on hills or near harbors. Buildings might be marked with colors or symbols that could be seen from sea. While churches and towers became more common later, the concept of signaling presence from the coast was already in use. It helped sailors distinguish settlements from uninhabited regions. In Iceland and Greenland, where the terrain was more uniform, closer observation was required. Small differences, the shape of a lava field, a slope's angle, or the color of a glacial edge, became crucial. Recognizing these markers could be the difference between finding a harbor or sailing past into dangerous waters. Modern reconstructions of Viking voyages show that coastal piloting remains practical. Crews on replica ships report that recognizing and following familiar land features makes navigation manageable, especially during poor weather. While GPS confirms position today, the essential skill is still to observe, recall, and adjust. Coastal piloting wasn't secondary, it was central to Viking navigation. The sea changed, but land endured. Sailing from one landmark to the next, Vikings followed a map made from memory, observation, and knowledge passed through generations. While Viking sailors preferred daytime travel, night voyages did occur. Whether driven by shifting winds, tight schedules, or the prolonged twilight of northern summers, there were moments when ships pressed forward after sunset. In these cases, when coastlines faded into silhouettes and landmarks disappeared into darkness, the stars became a quiet guide. Though no Viking star charts survive, the evidence suggests they relied on practical skywatching, based more on habit and observation than formal astronomy. At northern latitudes, stars move slowly in wide arcs. Polaris, the North Star, appears fixed in the sky, while others rotate around it. Long before magnetic compasses reached the north, this star offered a stable reference point. By keeping Polaris aligned over the prow, off to one side, or behind the ship, navigators could maintain a general heading. Though not positioned exactly at true north, Polaris was close enough for reliable direction keeping. This method of steering was most helpful on east-west routes. If Polaris remained fixed relative to the ship for several hours, and wind conditions stayed steady, the vessel likely held course. Cultures across the northern hemisphere used this method, and it likely formed part of the Viking navigator's approach. No tools were required, just clear skies and a trained eye. In the far north, high summer brought long daylight hours. Above the Arctic Circle, the sun sometimes never fully set, making star navigation impossible. But during spring and autumn, the night returned, offering opportunities to use the stars again. Norse oral traditions suggest familiarity with constellations like Ursa Major, known as the Great Bear. Its two outer stars point toward Polaris. While original Norse names may be lost, the patterns themselves were likely passed along through oral teaching and repeated use. The Milky Way also played a subtle role. This faint band of clustered starlight cuts across the sky and shifts slightly with the seasons. Though not precise enough for detailed navigation, it acted as a sky marker. Some early European texts referred to it as a road in the sky, and Viking sailors may have thought of it similarly as a visual band confirming direction or time of night. Star-guided sailing worked best in calm weather. During storms or overcast conditions, the sky offered no assistance. But on clear, windless nights, stars could keep a ship steady. Crews would watch a familiar star and steer to keep it in place. They knew when certain stars rose or set, and adjusted accordingly. It was not a system of exact calculations, but it was effective over short periods, enough to move between islands or maintain direction through a night leg of a voyage. The moon provided light but little navigational aid. Its position changed too quickly to serve as a reliable guide. However, the moon's brightness helped illuminate sails and waves. Some voyages may have been timed with full moons to increase visibility. Sailors also noted lunar phases when planning trips, especially as moonlight affected nighttime visibility and influenced tides. Aboard ship, lighting was minimal. Open flames were hazardous around sails and wood. Instead, Sailors used shielded oil lamps or torches sparingly. Most of the time, they allowed their eyes to adjust to the dark, enhancing their ability to track stars and observe subtle changes in cloud patterns. Without artificial light, the Viking night sky appeared dense with stars, offering a rich array for orientation. Younger sailors learned through repetition and guidance. An older crewman might say, "That star will rise past the mast by midnight," or "Follow the one that climbs over the eastern headland." Such instructions help tie celestial movement to known times and coastal features. Over time, these teachings formed part of the mental navigation map each sailor carried. Though less common than daytime travel, night sailing had advantages. A favorable evening wind could prompt departure, and arriving before dawn gave raiders surprise, or traders early harbor access. Navigating by stars gave Viking crews flexibility to move when others stayed anchored. Sagas describe departures in darkness and arrivals at daybreak, suggesting it was routine. Stars weren't charted but remembered. Patterns shifted seasonally, but sailors learned them through use. When land vanished and sea stretched ahead, Vikings looked upward not as astronomers, but as mariners guided by memory, observation, and the quiet stability of the night sky. In the absence of printed maps or standardized charts, Viking navigation relied heavily on place names. These names did not just identify locations, they described them. They encoded navigational cues and preserved communal memory. Each name conveyed what to expect before arrival. In this system, the landscape became a spoken reference map, passed from sailor to sailor through direct experience and repeated use. Old Norse is rich in geographic descriptors. Words like ness, headland, fjall, mountain, vikbay, and island were commonly used. Combined with descriptors, they form names like Scarthanes, Notched Headland, and Langi, Long Island. These names were practical. They referred to visible features, not abstract coordinates. If a sailor was told to steer toward Long Island, he expected a low, extended landform. Such names were repeated across the Norse world, from Norway to Iceland, the Faroe Islands, and Greenland. The repetition was resolved with context. Vesnus might refer to the western headland of one fjord, while Osnus described the eastern headland nearby. These directional cues made the names useful, while distinguishing similar features. Many names served as warnings. Heller Cliffs indicated steep terrain. Grafsfjall, Raven's Mountain, might suggest nesting seabirds, useful for locating fish but dangerous for anchorage. A name like Drungarvik signaled the presence of offshore sea stacks hazards to avoid when approaching in poor visibility. The names were learned, remembered, and connected to real terrain. If a fjord was called Djupavik, deep bay sailors could assume it was suitable for anchoring even before testing the depth. This naming system extended to sea routes and narrow passages. Channels between islands were sometimes labeled by the wind conditions they produced, or the currents they carried. A name like Stromfjordur, Current Fjord, told sailors to expect fast-moving water. In places where land was hard to see until close, names like Flatly, Flat Island helped distinguish subtle terrain. Naming was not poetic, it was practical, born from careful observation. Names could shift over time. Settlements grew, eroded, or disappeared. Volcanic activity reshaped coastlines, especially in Iceland. New names were created, but the method of naming remained. Describe what is seen, what is experienced, what matters. In this way, names became both descriptions and instructions. In Greenland, where the interior was impassable, naming focused along the coast. The eastern and western settlements developed their own local place name networks. These identified pastures, fishing grounds, hunting sites, and harbor points. A sailor leaving Bradolith, Eric the Red's estate, would know the next anchorages by name. He would know where to expect seals, where the wind changed direction, and where the coastline turned. The geography was memorized through its names. In parts of the British Isles where Norse settlers landed, many place names remain. Scapa Flow in Orkney, Snæfell in the Isle of Man, and Kirkwall, originally Kirkuvag, or Church Bay, show the Viking practice of naming places by observable features. These names offer modern clues to ancient presence. They also confirmed the Viking approach to landscape: identify, describe, and name for use. These names form the foundation for oral route descriptions. A journey could be described entirely through named locations, from Reykjanes to Eyjafjörður, then on to Skagastrand and Blönduós. Each name carried an image. The sequence became a mental path. With no need for maps, sailors navigated by recalling names in order spoken maps reinforced through conversation, instruction, and story. Children learned these names early. They heard them in stories and work songs, and from adults passing on directions. Fishermen taught the names to younger crew. Travelers recited them after returning home. Each repetition reinforced the connection between place and word. This transmission was not formal but communal, living in daily language. Some sagas include place name sequences. These are not incidental, they preserve route knowledge. When Eirik the Red sails from Iceland to Greenland, the saga names his stops. These names offer a record of known features along that route. Some carry mythological ties: a mountain shaped like Thor's hammer, or a bay linked to a local spirit, adding layers to the memory. Such associations deepen their grip on the navigator's mind. Scholars now use Viking place names to trace travel routes. Their repetition and structure suggest a naming system built for navigation. For Viking sailors, a name meant shape, danger, and direction. In a world without charts, coastlines were spoken shared through memory, grounding vast seas in familiar, practical language. Beyond the sight of land, Viking sailors turned to the sea itself for guidance. With no maps, compasses, or instruments, they studied the movement of waves, the rhythm of swells, and the subtle shifts in how the boat responded. For experienced crews, the surface of the ocean was not random. It carried signals patterns shaped by wind, weather, and distant storms. These signs, learned through repeated experience, helped them maintain direction across open water. The North Atlantic, where most Viking voyages occurred, is known for its deep ocean swells. These long rolling waves are formed not by local wind, but by storm systems far away. A storm off the coast of Greenland could send swells toward Norway long after the skies had cleared. These swells continued across hundreds of kilometers, steady in both interval and direction. Learning where they came from gave sailors insight into regions they could not yet see. Swells arrived in patterns. A sailor sitting low in the hull could feel their rhythm: one wave every 8 or 10 seconds, tilting the ship from one side to the other. If the boat rolled more heavily from starboard to port, the crew could infer that the swell was arriving from the northwest. This kind of interpretation allowed them to confirm that they were still on course, even without visual references. In calm conditions, the sensation became more obvious. With little wind and no surface chop, the deeper swell was the only movement. Even in fog or darkness, a navigator could detect whether the vessel's motion had changed. A new tilt or unexpected roll might suggest that the ship had veered off track or encountered a different swell direction. The body became an instrument, and the ocean became a kind of map. While documentation of Viking use of swell navigation is limited, scholars have drawn comparisons to other seafaring cultures, such as the Polynesians. In both regions, sailors navigated vast distances using only natural cues. Though these techniques left no written records, the logic is shared. Over time, the body learns to detect changes in the environment. Experience becomes memory, and memory becomes guidance. Viking ships were well suited to this method. Their shallow draft and open design made the boat more sensitive to wave action. Without high decks or enclosed hulls, the entire crew could feel how the water moved beneath them. Over time, this built a shared understanding. If the movement fell off, or if the swell shifted unexpectedly, the crew could adjust course. These small observations became part of daily sailing. Swell behavior also hinted at nearby land. As waves met islands or coastlines, they bent, reflected, or changed shape. A previously regular swell might break earlier or grow confused. Crossed wave patterns could signal rocks or submerged shoals. Long before cliffs appeared on the horizon, the sea's movement would begin to shift. Experienced sailors noticed these subtle signs and interpreted them as warnings. Ocean currents contributed to these observations. Though Viking sailors may not have named the Erminger or East Greenland currents, they likely felt their effects. Currents redirected swells, slowed progress, or changed water temperature. These changes altered how the ship moved, and over time, crews learned to associate certain sensations with specific regions. Swell navigation was not precise. It could not pinpoint location or calculate distance, but it added confidence to a broader set of techniques. Alongside bird patterns, sun position, known routes, and star visibility, it provided another layer of understanding. For long voyages between Iceland, Greenland, and North America, this sensory map made a difference. The sea itself became part of the toolkit. This knowledge could not be written down. It was physical, developed over time, and passed through experience. A creaking mast, the shifting sound of water, the familiar timing of a rolling wave, these became silent signals. Navigators didn't describe them with words. They recognized them through the body. Learning came from doing. Modern recreations of Viking voyages confirm this. Crews on replicas, like Snorri and Saga Sigler, reported sensing direction through the boat's motion. The swell became familiar, its rhythm instinctively learned. In Viking navigation, the sea was active signaling through patterns. Swells didn't replace sun or stars, but they quietly marked a path for those trained to listen. The Viking movement into the North Atlantic during the late 9th to early 11th centuries was shaped by repeated purposeful voyages rather than accidental discovery. Norse sailors crossed vast stretches of ocean to reach and settle Iceland, Greenland, and a land they later called Vinland. These journeys required practical knowledge of the sea and a flexible understanding of geography. Their success rested on memorized routes, seasonal patterns, and close observation of natural signs. The route from Norway to Iceland became one of the first major crossings. While Irish monks may have reached the island earlier, Norse settlement began around 874, when Ingolfur Arnarsson reportedly founded a farm near present-day Reykjavik. The voyage from western Norway to Iceland spans roughly 900 kilometers. Navigators had to cross the North Atlantic without visual contact with land for several days. To do so, they relied on seasonal winds, often from the northeast, and stayed aligned by following the sun and swell direction. Some crews broke the journey into segments by sailing along the coast of Norway, and then westward through the Shetland or Faroe Islands. These island groups acted as navigational stepping stones. From the Faroes, Iceland was approximately 450 kilometers to the northwest, reachable in a few days with favorable conditions. The presence of these intermediate landmarks reduced navigational uncertainty and allowed adjustments based on weather. Reaching Greenland posed a greater challenge. Eric the Red founded the eastern settlement around 985 near modern-day Qaqortoq. The route from Iceland's southwest coast to Greenland's southern tip covered nearly 1,500 kilometers of open ocean. Crews had to navigate through the Denmark Strait, a region known for strong currents, fog, and seasonal sea ice. The approach required precision. Miscalculating latitude risked overshooting Greenland or drifting into dangerous northern waters. To navigate this passage, sailors observed seabirds such as fulmars and kittiwakes, which tend to remain within range of land. Variations in water color, surface motion, or temperature also indicated changes. Land often appeared first as shadows or mountain peaks in the mist. These early signs, coupled with careful sailing, helped crews make landfall along Greenland's narrow coastal belt. According to the saga of the Greenlanders, Eric the Red returned to Iceland after his initial voyage to recruit settlers. In 985, a fleet of 25 ships set out. Only 14 arrived safely. The rest turned back or were lost. The attrition rate highlights the risks of the journey. Ships depended on wind, visibility, and coordination. Even with experience, crossing the strait was uncertain. Once in Greenland, Norse settlers established two coastal colonies, the Eastern Settlement and the Western Settlement, near what is now Nuuk. Though small and seasonal, these communities were linked by water routes and occasional voyages to and from Iceland. Ships traveled in summer, the only navigable season. These routes became familiar over time, contributing to a growing network of seaborne connection across the region. From Greenland, the Norse pushed farther west. Around the year 1000, Leif Erikson, Eric the Red's son, sailed in search of new land. According to sagas, he followed the coast of Baffin Island or Labrador before reaching a place called Vinland. This land was described as wooded, mild, and rich in resources. The exact location remains uncertain, but archaeological evidence from Lanceau Meadows in Newfoundland confirms Norse presence in North America. Vinland was not a permanent colony. Instead, it served as a temporary base for seasonal activity, timber collection, hunting, or exploration. Crews followed the coastline southward, adjusting course as they passed fjords and rivers. Like earlier voyages, they departed in summer, timed to the weather. Birds, sea patterns, and headland shapes helped in orientation. There were no maps. The sea was remembered through shared experience. These long-range voyages show Viking navigation's effectiveness. The Norse used no compasses or charts, relying instead on patterns, swell, sunlight, and animal behavior repeating trusted routes. Knowledge passed through families and crews, improving each expedition. Motivations varied. Some left due to conflict or land scarcity in Norway. Others sought opportunity. But reaching Iceland, Greenland, and Vinland took skill. These places weren't found by chance. They were reached, revisited, and taught. Routes were refined over time. The Atlantic held wind, memory, and purpose. Norse sailors moved with direction stored in mind and story. Settlements arose not just through sail, but through cumulative experience. As Viking sailors expanded westward into the northern Atlantic, they encountered more than ocean swells and rocky coastlines. Ice became a regular part of their environment. Drift ice, frozen fjords, and icebergs from distant glaciers shaped the conditions of sea travel. For voyages between Iceland, Greenland, and beyond, ice introduced risks that had to be read and managed. Navigating near the Arctic Circle meant developing awareness of signs not found in open water. Drift ice, or hafis, was common in the Denmark Strait between Iceland and Greenland. The East Greenland current pushed large fields of floating ice south, especially in late spring and early summer. These fields often extended into known sea routes. A voyage delayed by weather could run into unseasonal ice, blocking harbors or forcing ships to wait at sea until paths reopened. Before the ice came into view, its approach could be sensed. Water temperature dropped noticeably. The sea changed color, becoming pale or milky where fresh meltwater mixed with salt water. Sound also played a role. On calm days, the grinding of distant ice sometimes reached a ship's crew long before the floes became visible. Seabirds hovered near ice edges, feeding on fish stirred by meltwater currents. These small signals became tools for those who traveled regularly in icy waters. When ice was visible, longships had limited responses. They could steer quickly, but their open hulls were vulnerable. A single collision with dense ice could compromise a voyage. If trapped in a narrow channel or sudden fog, retreat was often safer than attempting to push through. At times, crews skirted the ice margins, watching for breaks. Gaps allowed cautious passage, but they shifted with wind and current, requiring patience and constant attention. Greenland's Norse settlements, including Bradalith and Herjolfsnes, depended on brief summer sailing seasons. Fjords remained frozen until late spring, cutting off travel. If ice remained into midsummer, voyages from Iceland might be delayed or canceled. Conversely, early melting allowed earlier travel, but unpredictable shifts in ice patterns made planning difficult. Still, ice was not always a threat. Icebergs served as location markers. Flat-topped tabular bergs, often originating from Greenland's eastern coast, gave sailors clues about current direction or nearby land, especially when fog concealed the coastline. Clouds also helped. On overcast days, when the sea blended into the sky, sailors watched for patches of brightness above the horizon. These bright spots, later called ice blink, reflected the presence of ice on the sea below. Even without seeing the ice itself, its presence could be inferred from the sky. This indirect visibility allowed ships to steer around hazards, even in poor conditions. While the term ice blink came later, the observation technique likely dates back to much earlier periods. Fog was another common feature of northern sailing. When cold air passed over warmer sea, dense fog banks could form quickly. When paired with ice, this made sailing especially hazardous. Reduced visibility erased the horizon, muffled sound, and gave no warning of nearby obstacles. Crews adapted by slowing speed and posting lookouts at the bow. The sound of water breaking against ice, or the creak of bergs shifting in the current, could guide decisions. In the quiet of fog, these small noises became crucial. The sagas seldom describe ice in detail, but its presence is implied. In the saga of the Greenlanders, one ship vanishes in fog and ice, while others arrive late. The tone suggests that sea ice was an expected hazard, not an exception. Sailors accepted these risks, building skills through repeated exposure. Navigating ice relied not on instruments, but on memory, experience, and shared knowledge. What worked one year might fail the next, but each journey refined awareness. In Greenland, hunters and sealers studied ice behavior seasonally, where it held late into spring, where it cracked early, and where open water channels, or leads, formed. Their insights, passed to sailors, contributed to a broader system of environmental understanding. Coastal dwellers, fishers, and crews built a collective mental map of the ice. In the 14th century, colder conditions of the Little Ice Age brought earlier, longer-lasting ice. Sea lanes narrowed, supplies faltered, and some scholars linked this climate shift to Greenland's Norse decline. Still, in earlier centuries, ice was manageable, a navigational factor, not a barrier. To Viking sailors, ice was a signal. It indicated wind, season, and bearing. Even in silence or fog, it could be sensed. They studied it, voyage after voyage, and learned to move through it. Aboard every Viking ship, one figure stood apart, not by title or strength, but by knowledge. The lead navigator was responsible for guiding the crew through open water, uncertain weather, and unseen hazards. This role was not assigned by rank, but earned through experience. Without compasses, maps, or instruments, Viking navigation depended on the trained senses of those who had made the journey many times before. There were no nautical charts. Navigators worked from memory. They had crossed to the Faroe Islands and remembered how the ocean swells changed just before land appeared. They had entered Greenlandic fjords and noted the color of the water. They had sailed under summer skies where the sun never fully set and learned to judge time from the sun's slow circle. Their skill came not from study, but from repeated observation and survival. On board, the navigator was not isolated. They advised the helmsman and coordinated with the crew. During daylight, they observed the sun's arc to estimate direction. At high latitudes, where the sun hovered for hours, this movement became a clock. If clouds covered the sky, the navigator used subtle cues, the brightness of reflected light on the sail, warmth on the face, or faint halos that betrayed the sun's position behind the clouds. With the sun gone, other methods came into play. The appearance of seabirds could mean land was near. Floating seaweed might signal a change in current. The feel and taste of water, more or less salty, could hint at nearby river mouths or melting ice. Every clue was registered. Small shifts in wind or surface ripple were noted, not in books, but in habit. The navigator responded not with sudden action, but with small corrections that kept the ship aligned. Communication was direct and functional. The navigator consulted with the styrboard side rudder operator. They tested younger crew by pointing to the horizon and asking what they saw. Lessons were given without lectures, through repetition and example. When a navigator said to delay departure or to change course, they were obeyed not because of authority, but because of proven success. Many navigators had crossed the same routes repeatedly. A sailor who had sailed to Iceland 20 times held the memory of how many days it took in clear weather, and when winds usually turned. A few had even made it to Vinland. These memories formed a mental map changing with each voyage, but grounded in repeated patterns. Sagas occasionally mention these figures. A ship that recognized a landmark or turned back at fog often did so because someone remembered a past journey. These small references, the Twin Hills, or the rising mist, show how experience shaped decision-making. Navigators were not just guides. They were keepers of remembered routes, fragments of which later appeared in storytelling traditions. Night brought other tests. Without stars, sailing usually paused, but under twilight or a clear moon, some travel continued. The North Star offered a fixed point, and groups of stars were recognized by seasoned eyes. The sea's movement also offered feedback. A subtle shift in how the boat moved across the swell could mean the ship had turned. Skilled navigators felt these changes and adjusted direction quietly. When mistakes occurred after storms or fog, the navigator was expected to recover. Waiting for sunrise, watching bird flight, or feeling wind direction could all help reorient a lost vessel. Navigators often corrected errors without panic, returning to familiar routes using remembered cues. Training new navigators took years. A young crew member might begin by identifying distant landforms or tracking the Sunday over time. They would learn to read wind, smell rain, and judge time by light. There was no formal instruction, just repeated exposure, steady observation, and correction. In coastal regions, some Viking navigators specialized in narrow areas, knowing where winds shifted at dusk or rocks hid beneath the surface. Their knowledge was local, consistent, and trusted. On longer routes, navigation relied on sensing subtle changes air before landfall or currents south of Iceland. These cues, minor to outsiders, were clear to the trained. Reputation mattered. A poor decision could end trust, while one wise choice earned lasting respect. Navigators held no title, but their skill was essential. Their knowledge wasn't written, it lived through experience, movement, and the crew's shared reliance on memory and proven judgment at sea. While Viking voyages across the Atlantic are well known, their explorations extended far beyond those cold waters. Norse sailors reached deep into Eastern Europe, the Black Sea, and the Caspian Sea. These expeditions required more than seafaring. Using rivers and coastal paths, they traveled without compasses or maps, guided by observation, memory, and a flexible understanding of the world around them. One significant route began in the Baltic Sea, where Viking crews, often called Varangians, entered the Neva and Volkhov rivers, moving south through river systems that connected them to the Dnieper. These inland paths allowed passage to the Black Sea and Constantinople, known to the Vikings as Miklagard, the Great City. The journey was difficult. Crews sometimes hauled ships across land to connect rivers. They navigated against strong currents and dealt with new terrain and unfamiliar communities. Still, these routes were used often, supported by archaeological finds along the way, including weapons, jewelry, and carved rune stones. Though this kind of travel differed from ocean crossings, the core methods remained consistent. Vikings read their surroundings, relied on passed-down knowledge, and adjusted based on local cues. Changes in water speed, bird behavior, or the shape of the land guided them. These signs, though unrecorded in books, offered dependable reference points. Upon reaching the Black Sea, or Eastern Mediterranean, Viking navigators entered a different environment. The climate was warmer, the wind patterns unfamiliar, and the coasts heavily populated. Yet they still watched the sun's arc and tracked wind direction. They followed coastlines and asked local mariners for guidance. Though they used different techniques, the underlying principle remained. Direction came from awareness, not tools. In Constantinople, some Norsemen stayed. Many joined the Varangian Guard, an elite unit serving the Byzantine emperors. Their presence is marked by runic inscriptions in the Hagia Sophia. These soldiers brought their navigation experience with them. Whether serving in the Byzantine fleet or advising others, their sea knowledge proved useful in southern waters. It's unlikely that Viking navigators adopted formal Byzantine techniques like portolan charts or magnetic compasses. However, they learned through observation. They noted how local sailors managed ships, how Mediterranean winds behaved, and how constellations differed in southern skies. They tasted river water for signs of melt or sea mix. They recognized swell differences in new regions. These sensory inputs helped them adapt their methods to new settings. Other Vikings traveled farther east, using the Volga River to reach the Caspian Sea. These were not exploratory missions but trade journeys. They exchanged goods with Persian and Arab merchants. But even commercial voyages required careful timing and skilled navigation. River levels changed with snowmelt. Sandbanks moved. Travel windows were determined by observation, not fixed calendars, but seasonal knowledge. Vikings returning from such voyages brought with them broader mental maps. They had seen distant coasts, heard new words for wind, and encountered unfamiliar boats. Some of this knowledge entered the saga's mentions of cities, birds, or rivers far from Scandinavia. These details, though stylized in storytelling, reflected real experiences. The purpose of these expeditions was trade. Goods like furs, amber, ivory, and slaves were exchanged for wine, spices, silk, and silver. But all trade depended on movement. Safe travel, correct timing, and proper routing determined success. Viking ships, though built for the sea, were flexible. Crews adjusted easily to river conditions, relying on observation to guide decisions. Some Norse navigators became regional specialists. Slavic and Arab sources mention northern sailors hired to guide unfamiliar waters. These men were valued not for strength but for their mental maps. They knew which fork in a river to take, which town to avoid, and which cove offered shelter. In places where maps did not exist, such knowledge was vital. As Viking travel expanded, settlements became increasingly connected. A coin from Samarkand might reach Gotland, and a trader in Hedeby could handle goods from Novgorod. These networks existed through memory, mapped in the minds of navigators. No paper charts guided them, but the routes were known. Viking navigators relied on sun angles, river currents, cloud shifts, and unfamiliar bird calls. They observed, listened, and adjusted. Direction came from attention, not instruments. These invisible paths, formed by experience and memory, were traced one bend or shoreline at a time. Held in thought and shared stories, they remained unwritten, but reliably carried across vast distances. In Viking communities, learning to sail was a normal part of life, not a specialized craft. Children who lived near the sea absorbed maritime knowledge from a young age. There were no schools or written manuals. Navigation was learned through repetition, observation, and experience. Knowledge passed from one generation to the next without formal training. From early childhood, boys and sometimes girls watched adults prepare ships, discuss the weather, and share stories of long voyages. These stories included more than adventure. They conveyed practical details: how long it took to reach Iceland, what birds circled near land, and how the sea changed color before a storm. This information became part of everyday understanding. A child's first experience aboard a ship often came during a local journey. They joined a parent or relative on a fishing trip, or traveled along the coast to a nearby market. These short voyages taught basic awareness: how to shift weight on a moving deck, how to tie knots, and how to respond to changing wind. The sounds of the sail, the splash of the oars, and the motion of the boat became familiar. By adolescence, young people joined longer trips. They still did not lead, but they watched carefully. They noticed how the sun moved and how sails were adjusted to keep course. They learned to recognize distant land by how it slowly rose on the horizon. Changes in watercolor or wave direction were also important signs. Each journey deepened their practical knowledge. Older sailors used questions and demonstrations to teach. They pointed to changes in the sky or water and explained their meaning. A steersman might ask why a sail was angled a certain way, or why the ship followed a particular coastline. The process encouraged active observation. Young crew members learned by seeing and doing. Timekeeping without clocks was an essential skill. Navigators judged the time of day by the sun's position. Apprentices were asked how long until midday and were corrected based on the light's angle. Distance was measured by counting oar strokes, observing how fast waves passed the hull, or singing familiar songs during a known stretch of travel. These indirect methods created a shared sense of timing. At night, they learned to read the stars. The North Star served as a fixed point for direction. It remained stable while other stars rotated around it. Young navigators were taught to find it and use its position to maintain course. Other constellations, such as the Big Dipper, helped complete the mental map of the night sky. This required clear skies and patient observation. Practice was key. On calm days, apprentices might take control of the ship briefly, guided by elders. If the ship drifted or responded poorly to wind, corrections followed. These moments were not failures, but opportunities to learn. Knowledge came through repeated effort and response to real conditions. Confidence was earned by solving problems, not avoiding them. Memorization was another tool. Apprentices learned the names and traits of local harbors, reefs, and islands. They recited lists of landmarks in order, sometimes as chants. These sequences helped them remember routes. Before major trips, crews often reviewed these sequences together. This built a shared memory of the landscape. Experienced navigators used questions to test knowledge. What would you do in fog? How can you tell if we're drifting too far east? These scenarios encouraged flexible thinking. Navigation involved more than memory. It required calm decision-making, alert senses, and clear judgment. Full responsibility came only after years of demonstrated skill. Even then, mentorship continued. New navigators began with familiar routes before taking on longer journeys. Their decisions were observed. Trust built slowly. A single mistake in judgment could put the ship at risk. Reputation alone was not enough. Every navigator had to earn the confidence of the crew. In some cases, navigational roles passed within families. A son might inherit his father's ship, but knowledge had to be proven. Memory of the sea could not be transferred by name alone. It had to be lived and tested under sail. Each generation added its own experience to the shared body of knowledge. Viking navigation endured through practical learning based on observation, memory, and repetition. Without charts or tools, sailors relied on what they saw, heard, and remembered. Each voyage deepened their understanding. In recent decades, archaeologists and sailors have attempted to retrace Viking routes using reconstructed ships. These experimental journeys offer insight into how Norse seafarers may have traveled without maps, compasses, or modern tools. Ancient sagas and scattered finds provide clues, but only through sailing can certain aspects of navigation be understood. One early reconstruction was the Hugin, a Danish-built longship launched in the 1942. It crossed the North Sea from Denmark to England, showing that such vessels could survive the open ocean. Later, in 1970, Norwegian adventurer Ragnar Thorseth built the Saga Sigler, which sailed thousands of miles, reaching North America and the Mediterranean. These journeys tested Viking ship design and navigational practices under real conditions. The Snorri, constructed in 1997 in Iceland, directly followed the route described in the Vinland sagas. The ship sailed from Iceland to Greenland, then crossed the Labrador Sea to reach Newfoundland. The voyage relied on sun position, wind shifts, and ocean patterns. The crew faced fog, cold winds, and no GPS. The success of the journey confirmed that distances described in the sagas were possible with only natural navigation techniques. One key challenge was poor visibility. The North Atlantic often lies under fog or low clouds, making solar tracking difficult. To test alternatives, crews experimented with sunstones crystals said to locate the sun in overcast conditions. Using Iceland's spar, they found it possible to estimate solar position with minimal error. While it remains uncertain if Vikings used sunstones, modern tests show the method could have worked in northern sailing conditions. Other experiments focused on how longships handle the sea. These vessels, with shallow drafts and symmetrical hulls, behave differently than modern boats. They ride the swell instead of cutting through waves. Modern crews learn to feel the boat's subtle shifts to detect drift or course changes. In long voyages, the boat itself becomes a guide. Its pitch, roll, and movement offer silent signals to attentive navigators. Duties aboard these voyages are shared. Crew members rotate between steering, watching, and navigating. This reflects Viking practices, where multiple sailors likely held some navigational knowledge. The work is constant, raising or lowering sails, switching from rowing to drifting, and responding to storms are done through habit, observation, and cooperation. Formal instructions are rare. Decisions are made collectively, based on wind, wave patterns, and sky conditions. Modern reenactments emphasize patience. Viking ships were fast for their era, but still at the mercy of weather. Progress could be slowed by calm seas or reversed by wind. Crossings took longer than planned. This suggests Viking voyages were rarely precise. Crews adapted to conditions, waited when needed, and used accumulated knowledge rather than fixed timetables. Conditions aboard are also harsh. Open decks offer little protection. Rain, wind, and cold affect sleep, food, and morale. Crew members sleep in shifts, often wet and exposed. Food must be carefully stored. Reenactors report fatigue, cold hands, and sleepless nights. These difficulties, not detailed in the sagas, provide new perspective on the endurance needed for Viking sailing. These voyages also highlight shared awareness. Crews often begin to notice small environmental signs, bird calls, wave changes, distant smells, just as Viking sailors would have. Some experimental crews avoid clocks and charts entirely, relying on oral instruction and instinct. Moments of confusion often resolve through attention and repeated experience. Knowledge becomes physical, not just remembered but felt. Return journeys often prove more difficult. Planning the route back requires attention to seasons, supplies, and wind. This supports the idea that Viking navigators were skilled planners, aware of timing and environmental cues beyond their destination. Several Viking ship replicas remain in use today. They appear at festivals, teach history, and continue to test theories. Each voyage adds to understanding. These experiments do not answer every question, but they show what is possible. They demonstrate that Norse navigation was not dependent on luck. It was skill developed over generations. By retracing Viking routes, modern crews demonstrate that ancient navigation methods still work. Today's sailors confirm the sagas. People once crossed oceans using sun, sea, wind, and memory without instruments. Attention and patience guided them. The tools were basic, but the practice was refined. These reenactments reveal Viking navigation was practical, replicable, and grounded in a learned, enduring mindset. By the 12th century, the age of Viking expansion was fading. The long-distance voyages that once linked Norway, Iceland, Greenland, and Vinland became fewer. Political centralization, shifting economies, changing climates, and the rise of new tools began to replace the Norse navigational methods. Traditional skills rooted in wind, light, and memory slowly gave way to instruments, charts, and formal routes. In Greenland, Norse settlements continued for centuries after their founding in 985 CE. The eastern and western settlements traded with Iceland and Norway, but colder conditions during the Little Ice Age made sailing more dangerous. By the early 1402, both settlements were abandoned. Isolated from Norse contact, future generations may have lost the skills needed to return. In Iceland, the shift was slower. Travel and trade became organized. Navigation moved from oral knowledge to written guides and external influences. The magnetic compass reached Europe in the 12th century and spread to the north in the following centuries. By the 13th and 14th centuries, it appeared in northern shipping. The compass allowed travel even in fog or at night, unlike Viking methods which relied on visible sky and sea. With the compass, local knowledge became less necessary. Environmental cues like sun position or swell patterns were replaced by directional bearings. As this tool became more common, the value of traditional observation declined. Ship design also evolved. Viking longships, with shallow keels and symmetrical hulls, worked well in rivers, fjords, and coastal zones. They could land on beaches and be rowed in still water. Later European ships, such as cogs and caravels, had deeper hulls and larger storage capacity. They were suited to long-distance trade but required ports and deeper channels. As these ships dominated, navigation adjusted. Predictability and cargo space took priority over adaptability and environmental reading. Political changes reinforced the transition. Scandinavia shifted towards centralized kingdoms. Maritime activity became regulated by monarchs and guilds. Toll systems and port laws structured trade. Training moved from families to institutions. The role of the individual navigator, once based on earned trust, was replaced by written rules and assigned duties. The instinctive skills of seasoned seafarers became less relevant in a world focused on documentation. Literary changes reflected this shift. The Icelandic sagas written in the 13th and 14th centuries often mentioned travel but gave little detail on how voyages were navigated. Directions were vague to the west or across the sea. This may indicate that navigational methods were already fading from memory. Once the techniques were no longer passed orally, they disappeared from the written record as well. Place names still preserve remnants of Viking navigation. Along coasts in Iceland, Greenland, and parts of Canada, names such as Seal Bay or Whale Sound may once have guided sailors. These names likely served as references for direction, timing, or resources, but as time passed, the meanings behind them were lost. The names remained, but their purpose as navigation aids was forgotten. Some aspects of Norse navigation lasted longer in remote areas. In parts of Norway and the Faroe Islands, stories persisted into modern times of men who could read waves or smell land. These skills were passed on informally, but eventually eroded as mechanical tools, and formal schooling became dominant. Observation gave way to measurement. By the 15th century, Portuguese and Spanish fleets explored the Atlantic using compasses, astrolabes, and charts. Viking navigation, based on embodied experience and oral tradition, did not align with the demands of these new imperial expeditions. It was not considered reliable or precise enough for state-sponsored ventures. The final recorded voyage from Greenland to Norway took place in the early 1402. Afterward, Norse Greenland disappeared from the record. Iceland remained a maritime culture, but its methods shifted. Sea routes were drawn, not remembered. Sailors used measured bearings, not bird flight or sun arcs. The earlier practices, feeling wind, watching light, reciting rhymes, were no longer part of formal navigation. By the 16th century, Norse navigation had faded. European systems favored instruments, written instructions, and established ports. Skills once passed orally through seafaring experience were no longer used. What survived were place names, story fragments, and the legacy of sensory-based travel. As open boats and uncertain waters disappeared, so did the need for traditional methods. The tradition ended through change, not failure.